A circular racetrack of radius r is banked at angle theta. If the coefficient of friction between the rod and the tires is mu, show that the maximum permissible speed is given by this one, Vmax is equal to square root of Rg brackets tan theta plus mu, everything over 1 minus mu times theta. So this is the question that we're going to do, or this is what we're going to do. We are going to prove that the maximum permissible speed is given by this. Now you know when a vehicle is moving and as it approaches a corner, which is banked, the road that is banked at a certain angle, the maximum permissible speed is found using this formula. So let us try to see what we can do. We have a road. This, okay, we do this diagram. So here it is banked at this angle theta. Then when a vehicle is coming, let's say the vehicle is here. Okay, so here there is the weight of the vehicle here will be this one, mg. Then there is a force that is acting in this direction. Let me just separate this. There is a force that is acting in this direction, which is the normal force. Then we can resolve this. Okay, so this theta and this theta must be equal. So this one we have, okay, we have this one. We are resolving now. So this one, the side that is adjacent to this angle, this is n cos theta. Then this one becomes n sin theta. Then as it approaches the center of the circular racetrack, there is centripetal force in this direction. And when it is coming this way, there is a force that is opposing the motion. When it is coming this way, then the friction force, which is the opposing force, will be in this direction. So this is friction force. And at the same time, we can assume also to say if, let's say if there is an upward motion, like when it is moving in this direction, then the friction force will act in this direction. Now, let us resolve these forces. We know that if the forces are balanced, the summation of forces in y must be equal to 0, and the summation of forces in x must also be equal to 0. So we have this scenario where we say summation of forces in x must be equal to 0. So in x, say we have this one, we have n sine theta, n sine theta. So okay, there's also friction force here, friction force, then Fc minus Fc. This should give us 0. So we have n sine theta plus Fr. This will give us Fc. And Fc is given by mv squared over r. This is centripetal force. Force is equal to ma, and m, this is the mass, this is the acceleration. So centripetal acceleration is given by v squared over r. Let us call this as equation 1. So from this, let us also proceed to the second. Let us also do summation of forces in y. So summation of forces in y must also be equal to 0 minus Fr, which is this one, minus mg is equal to 0. So we have n cos theta minus Fr is equal to mg. Let us call this equation 2. Now, let us resolve for friction also, since we know that this is like this. So let us keep this question, these equations, equation 1 and equation 2, and let us resolve for friction. Okay, so friction, we can resolve right from here. So it was going in this direction. Then we have, okay, so we have, this is theta, so the we have friction force here. So the line that is the one that is adjacent, okay, we have this. So this one it is FR cos theta. This is adjacent to this. Then this one it is FR sine theta. We are resolving for this. Okay, so this component, we have this one is coming in this direction, this one. Okay. All right. We know that if we have an object such as this one, then there's normal force that is acting in this direction, and okay, of course, mg. If an object is moving in this direction, then there will be an opposing force that will be in this direction, which is the friction force. And this friction force is given by Fr is equal to mu n. So let us get this and plug it in the first and the second equations. What is this? We put that. But since it is at an angle, we are going to put just as we resolved. So we have n, okay, n sine theta plus mu n cos theta n sin theta plus mu n cos theta. This will give us mv squared over r. So let's call this as equation 3. Then we had n cos theta minus fr. So the way there's fr, we put mu n. Then we had sin theta. This must give us mg. So let us call this equation 4. So we can factor out n, since it is common. If we factor out n, we are going to have n here is equal to this one. So n will be sin theta plus mu cos theta. This will give us mv squared over r. So then we have from this, if we factor it out, we are going to have n. Then we have cos theta, cosine of theta minus mu. This is sin theta, which will give us mg. So let us make it the subject of the formula from here. We make n the subject. Cos theta minus mu sin theta. This is mg. So dividing through by this, we have cosine theta minus mu sin theta. Also here, by the same, minus mu sin theta. So that this and this will go. And what we're going to remain with is n is equal to mg over cos theta minus mu sin theta. Okay, so let us say this is okay, this is equation number 5. Then we say this is equation number 6. 6 into 5, we are going to have, so where there is n, we are going to replace it with this one. So here, let me erase the top part. We have, so n, we put mg over cos theta minus mu sin theta. Okay, so here, then everything times sin theta plus mv squared over r. So this one can be simplified as, so we have this one, sin theta plus mu cos theta over cos theta. This should give us mv squared over r. But m and m will cancel. And from this point, what we're going to have is Sin theta plus mu cos theta over cos theta minus mu sin theta. This will give us v squared over r. Since we want to make v the subject, we are going to cross multiply. If we cross multiply, we are going to have this one will be v squared. If we cross multiply, so it will be r times g and everything in the brackets here, sin theta. Okay, we are drawing close. Now let us finish if we can. Let us see if we can finish. So we know from trig ratios, if we want, we can just introduce the square root from here. We introduce the square root. And what we're going to have is, so this square root and this square will cancel, and we're going to have this one. Okay, we have Rg sine theta plus mu cos theta over cos theta minus mu sine theta. So this must be like this. So now, the question, in some books, they are just going to end here, but we can go further by dividing throughout by cos theta. And if we do that, we are going to have v is equal to square root of Rg, then everything here we have sine theta over cos theta plus the top part, just the top part, we have mu cos theta over cos theta over cos theta over cos theta minus mu sine theta over cos theta. But we know from trig identities to say sine theta over cos theta is tan theta, and cos theta over cos theta is simply 1. So this one is 1, this one it is tan, and this one is okay. So let us see where we are going. So we have v is equal to Rg, then this one over this one, sin theta over cos theta is tan theta, mu cos theta over cos theta, we have just mu, because this one and this one we're going to have a 1. Then here we have cos theta over cos theta is 1 minus mu sin theta over cos theta is mu tan theta. Now everything in square root. So this is V max. And this is the expression that the question demands us to find. Thank you so much for watching the video. For this and more, remember to subscribe and turn on the notification bell so that every time I post a video,